So one of the things I've got to do on this LS101 is replace this battery because it's dated August 1987. So obviously that's when it's made. It's like 33 years old, still going. It's pretty amazing. I don't know how much longer it's going to go on for, so obviously we need to change that battery. So I've got a battery here which I prepared. It's the same battery as I put in the other unit. I don't know how long this is going to last. Hopefully it lasts 10 years. You know, be good if it does 10 years. I've already prepared it, so it'll drop straight in there. What I've got to do, obviously, is change it without losing the calibration data. I don't know if the data's in here is any good anyway, but it is what looks like to be correct. But it is obviously out of calibration for sort of, probably could be this board even that's wrong. So the values are off, but they're all consistently off. It does have calibration data in there, so I don't lose that unless I need to, you know. So I'm going to replace this battery without losing power. Depending on the gear you're working on, you can do that easily. Sometimes it's not so easy. Sometimes you have to strap a supply across it and then use an earth isolated soldering iron, maybe a gas iron or battery powered iron, that kind of thing, to desolder the battery. There's no physical connection electrically between the iron you're using, the earth, and the unit, otherwise you'll short it out. In this particular item, it's got parallel diodes, so the feed from this battery goes through a diode, and the 5-volt supply, which tops up the memory when it's running, which powers the memory when it's running, also goes through a diode. So the diode isolates from each other as two supplies, which means I can work on this with it powered, which is good. It means I can take the battery out with the power on and insert a new battery, and then it should be okay. However, you still have to be careful. You still have to have an isolated soldering iron, otherwise you could still be shorting out the supplies. Now the other thing you got to do is also do it in the right sequence as another precaution. So if you desolder the positive first, the negative could be earthed, and if you're desoldering that one, you'll be shorting the battery out. So to take the battery out, take the negative off first, then do the positive, and then to fit the new battery, you put the positive on, then the negative. That way you're not potentially shorting out the battery. So that's the plan. So I've got my TS100, I got this for review some time ago from Banggood, but it's good for things like this where you need an isolated iron which isn't earthed. But there's no earth connection on this thing. So I should be able to actually measure between this and a chassis which is plugged in and not get a connection. In fact, I shall verify that. So here we go. So I've got the iron, I've got the probe in the earth point, and let's go to the negative side of the battery, and we're getting mega ohms, which is perfect. We've got the positive side, I should also get a significant amount, but it's going to be a bit crazy because it's positive side. So there is some kind of connection in mega ohms to the negative side, but this is going to be, doesn't like that. Anyway, so it's not a direct connection, so mega ohms is fine because it's not going to short anything out through mega ohms, which is great. That's exactly what I want. So let's do this. Let's power this on. I should really turn the power on to the supply first. Right, so the unit's on. Be very careful. You can cause all kinds of damage if you're not careful. Right, set to 300. Okay. And what I think I'll do is I'll put a little bit of flux on here actually as well while I'm waiting. Just to help it desolder. Just a little bit. I'll probably put some more on as well when I actually go to do it. Right, 300. Now don't short across anything else. Probably should put some fresh solder on this tip too. Anyway. Right, there's negative out. Now it's to the positive. Come on, there we go. Let's pull this out. Hopefully that's shorting against anything. Next battery in. This just pushes up a bit so I don't touch it. Oh, the battery clip's broken. That's inconvenient. Okay, I have to do something about that. Glue it together or something to figure that out. This one's actually a little bit cold for my liking. Should probably go a bit hotter anyway. Job's almost done. I tend to use a hot iron. I tend to, like my other one, I run about 380, 390. So, bit of a difference. Let's put some fresh solder on this. And that. That's melting the bloody insulation that's on there. Of course it is. Right. Try and find a hole in the board and push that through. Come on, where's the hole? leave it on lead acid as heat sinks to try and minimise the melting of the plastic. Right, that's in place. Yeah, it's a shame about this being broken. I have to do something about that. Wish I'd done that as broken before I pulled it out. Maybe I would have 3D printed a new one. Never mind. Anyway, I was committed to getting this done, so that's all connected across there. Just do a voltage check to make sure it's all good. Just be absolutely confident it's all connected up alright. It should be fine. I mean, I don't see how I can get that wrong, but you never know. Something horrible could happen. I expect to recalibrate this thing anyway, so it's not too big a deal if I, lose the data. But I prefer not to lose the data. I've got my probes back to front. How do I do that? That's better. Okay. So negative there. 2 over here. 2 over here. There we go. And then it passes through here to that diode there. Add that diode there, and there's the power, 4.5 volts coming through from the other side, which is the diode drop resistance, because you've got a 5 volt supply coming through here. Then the diode drop across there to 4.5 volts. So that's what I mean, powered all supplies. So turn it back off, and we should definitely be getting a decent supply across here if we can get the probe in. The point there should be down 3.6. Yep, that's fine. It's working alright. So hopefully calibration data is not lost. So that's something you can do. You have to think about what you're doing about the entirety of the circuit. You're not just thinking, okay, is it the voltage across this battery? No, you got to think about the voltage of the soldering iron, the earthing, and the whole entirety of your test setup. Now a lot of times when you're doing gear, you have to think about the test setup as a whole anyway. The earthing of the scope probes, that kind of thing. You can't get an earth clip of scope probes and shove it anywhere in a circuit, for example. The test is getting something. You can't do that because you'll short it out because there's an earth. Same thing with a soldering iron. So most people already realise this. Well, a lot of people which are used to doing electronics work are aware of this kind of thing. But if it's not something you're used to doing, or you're not really thinking about that kind of aspect of it, then I thought I'd mention it so it doesn't catch you out and give you a really bad day. So this is the battery we took out. You can see, there you go, August 87, and there's all the information about it. Hey, West Germany. I suppose DFME would have included that, wouldn't it? Interestingly, it's got SL150. Is that shelf life? Does 150 mean 150 months? So it'd be, what's that, 12 years? Quite possible. I'm guessing, obviously, I've got no idea, but it just seems a bit coincidental that a battery of this type would have an SL of 150, which would be about 12 years, which I think would be an expected lifetime. So 30 years later, still going. That's some good German engineering back then, it would seem. Well manufactured. So out of curiosity, I thought I'd just see how much power is actually left in this battery. Now it's been there for 33 years, or at least it's been 33 years since it was made. Who knows? Maybe it's 5 years later or something got put in. Who knows? I doubt it's the original battery because this is dated 1985, at least from what I can tell. This is dated 1987, so chances are this is a replacement battery, the very first replacement battery that got left in it. So I thought I hooked up to my Siglent electronic load, and I'm going to discharge it in battery mode down to 3 volts, and then I'm going to see how much power comes out of it. And it will just be interesting to see how much is actually left. So here's the electronic load. As you can see, I've got it set up for a 5 milliamp draw, and you want to see it on here, but the second page is a 3 volt cutoff. So it will discharge on the 3 volts, and then it will shut itself off, and it will tell you on display how much power actually drained out of the battery. We'll give this a go. We'll get this thing running, and we'll see how it ends up. You ready? That's a 5 milliamps. So I'm going to leave this going and see how long it takes to drop down. It will tell us how many milliamp hours are left in it. Plus to get down to, I suppose 1200 milliamp hours total capacity, something like that. Actually, thinking about it, what I'm going to do, I'm going to reduce this discharge current slightly more. I'm going to make this, I'm going to go for 2 milliamps. Right, go back on. Reason being is this is meant for a very low drain device. It's supposed to have very little drain on it. So putting a heavy load on, even 5 milliamps is probably excessive. And these things normally have nanoamps drawn from them. So to be realistic about their actual usage, and I run it on that for a while, we'll see how that goes. It's obviously right on the bottom end of the scaling on this thing what I can actually do. It needs like one more decimal place for something this low current. Anyway, I'll leave it going and we'll see if we can get anything out of it really. Be interesting to see what the result is. Well, it's been 15 minutes and it's still going perfectly happily, so maybe I will up the current a little bit more. Maybe we'll go back to 5 milliamps again. I don't want it to take 2 or 3 days to discharge this thing. So I've been doing this battery drain testing on this thing for, well, a period of days now, off and on. Just accumulating all the data. I've got another 100 on here basically. So I think about 350 milliamp hours already drained out. And what I've been finding is a bit of a weird anomaly here. When I first started doing this drain testing, I couldn't do like 10 milliamps or so, 25, even 20 milliamps, couldn't do it because the battery voltage just dived. What I've been finding now is I've actually been able to gradually increase the current. So I was actually doing like 2 milliamps because it would dive, you know, and 5 milliamps, that sort of stuff. So I did really gentle loads initially for the first day or so. I've been gradually creeping up each day. And it's actually been holding. So now I can actually do 20 milliamps and it's holding 3.1 volts. Well, I couldn't do that originally when I first started doing the testing. So the battery is actually improving in its characteristics. It's like it's fixing an internal fault or something. It's a bit interesting. You know, you think that as it drains it'd be a bit less capable, but it's actually getting better. It's a bit odd and surprising. Anyway, so it's only 20 milliamps I'm doing now. I mean, so I was doing 2 or 3 milliamps for the first day. You know, just really slowly creeping it up. I mean, I've done like 350 milliamp hours on it already. It's still going, and this thing's dated 1987, and it's sitting at 3.1 volts, so 20 milliamps coming out of it. The fact I've been doing that for a few days now, on and off, probably 4 days, I think I've been doing this now. So if it's drawing nanoamps, this thing's still had a few years left in it yet, even though I've changed it, you know, based on how it's performing, and it's fine. It's like shelf life is the limitation on it. It's still got heaps of capacity. It's interesting, but that is actually performing really well. It's almost like I probably didn't need to change it. Maybe what I should have done is load it up a little bit like I've done, and put it back in, because it seems to be getting better and better. Very weird. Anyway, I thought you might find it interesting. Well, the battery test is finally finished. I've been running this for about a week now, off and on, trying different currents, that sort of stuff. And the weird thing was, I couldn't draw much current. I could only do like 5 milliamps or so, and even then it struggled to drop off. Then over time, it actually got better and better. It was really weird. And I could actually put up like 25 milliamps in the end, and it's still holding. So it sort of peaked, and then it started coming back down again. And the last test I was doing 6 milliamps. Anyway, it's finally dropped down to, I said 2.8 volts here. I dropped it down quite low. You'll see here I've got 174 milliamp hours on here already. Plus I've got a whole bunch clocked up already on the other side. Plus 805 I'd already done. Pulled out of that battery from 1987. That is incredible. I'm actually incredibly surprised by that. Now the behaviour was interesting, where obviously it was doing that. I couldn't handle high current initially, so you think, oh yeah, the battery's pretty dead. But because I was gentle with it, it seemed to sort of recover, and then it did alright. Right? It still had 1,000 milliamp hours left in it. It's a 1200 milliamp hour battery, so it's only used 200 milliamp hours in 30 years. Wow. Obviously, it depends on what the specs are for these. I mean, I don't actually know, but the spec is this. 1200 milliamp hours are going to be based on a certain C rating of discharge, you know. So, but these are made for memory backup services, so they're expected to have very low discharge rates anyway. Yeah, that's surprising. It did so well, and as you can see, it did 8 hours at 6 milliamps, well, 8.5 hours on that last one. Plus that, I mean, that's incredible. I'm actually, that's what I got on here is what I was kind of expecting. Plus the 805 I got earlier. You know, wow, that is really surprising. So yeah, that basically was shelf life, as they say, you know, because the currents and the Datrons obviously picoamps or something to keep the RAM going. But incredible. I really wasn't expecting that. Not after 30 odd years. Is it 33 years? So that's a well-made battery. But they don't make it anymore. Alright, it's been a while. Back onto this thing. I haven't touched it in a little while. I don't know, a month or so. I've actually forgotten where I'm up to, but I did have it basically working. I had that much figured out. I think I just had to look at the calibration side of it. So we're going to power it up now. I've already got power going into it. Flick the power switch on and see what the story is with it, and just do some basic tests and just re-establish what was going on, because I've forgotten. It's a bit of a shame that this side of the casing is completely smashed off, but oh well. Yeah, it's devalued it somewhat, but anyway, at least it does kind of work. So we'll move on. Alright, let's power it up, see what's going on. Let's wash some dust off. Okay, it boots. Yay, that still works. Let's plug some power into it. It's a DC, we're still going to auto range. I've already got my PDVS2 set up over the side here. In Johnson's PDVS2. I powered up like a minute ago, give it a chance to warm up a little bit. Let's plug this in and we'll see what we get out of it. So it's currently set at 0 volts. I need to sort of figure out how I'm going to set this up so you can see both. Let's do 1 volt. 1 volt is okay. 5 millivolts off. Same for 2 volts. 9 volts is about 50 millivolts off. So as it scales up, it's like the second digit here is off by 5. That's what it looks like, doesn't it? So that's off by 5. If I go into the next range down, which should be 1 volt range, that one there, the same digit's off by 5. It's not the second digit. Third digit is off by 5 in that case. Okay. If I do 100 millivolt range, first digit's off by 5. So what is that decimal? I suppose. But you can say it's always that decimal there. That one's already off by 5. That's off by 5. Also, it's off by 3 there. And towards the range 5. Same decimal point. So, okay. Well, what I'm thinking that we need to do is go through the DC board calibration. This one here, which is underneath right here. Actually, I could just probably calibrate the whole top section and see how that goes, because the DC board affects everything else. Okay, all the readings go through it. So if this board here is slightly off, then everything will be slightly off. And that's what I think the situation is. Now if I can just do the DC board only, maybe the digital calibration is still okay. Right, and that may mean that the rest of the calibration points are still good. If I just do this board, that might be all I have to do. There's a couple of references on this board you have to do as well. I can do those, a couple of adjustments, not much. So I'll do those digital adjustments first, then we'll go over and do the digital board, and this DC board, and then we'll see how everything else looks after that. I do remember the resistance measurements and the AC measurements were off as well. I do remember that much, so that's what we're going to tackle. Alright, so the test point I'm doing now is one of the digital board assembly sections. So this is the first step, which is to disconnect all these ribbons and stuff down the side, down the centre plane. So there's no supply, obviously no power on the unit either, it's all turned off. I'm injecting 4.75 volts into the test points, which is TP8 over here and TP28, which is 0 volts ground. And I've got my scope probe hooked up here, which goes to this test point over here, which actually goes to pin 40 of this chip. Now what I've got to do is actually adjust R83, which is over here in this corner, which you can't quite see, to get a transition on the scope. So when I see that transition, then I am at the right voltage level at this point. I'm not quite sure what the adjustment is actually supposed to do, but it's supposed to see a transition. I'm not sure I've got my scope set up properly actually. It's like I should be on DC coupling, not AC coupling, because that makes a bit more sense when trying to measure at DC, doesn't it? Okay, right, let's do it again. Here we go. So I'll show you that transition in a second. Let's change camera views and I'll show you what's actually happening. So the actual step says R83, turn it fully clockwise, which it currently is. And that gives me this high state over here. Ignore the voltages, potentially. I'm not quite sure what coupling I'm actually on. Probe says 20 times, so it's completely wrong. I'm using a 10 times probe, so let's adjust this, shall we? Let's get this right. Okay, 10 times probe. And then as I turn this R83 anti-clockwise, it's supposed to get a transition. There you go, just there. It says as it goes from high state to low state, or as it starts pulsing. So you have to get right in that position where it's just starting to cut out. So I'll put it back. About here somewhere, there we go, about there somewhere. So that's set, that's right as it drops, is where I'll stop turning it. So that's that particular done. And I'll show you the adjustments of this. Okay, so there it is, right there, right in the corner. You can see, it's probably getting washed out a little bit by lights, but right there, that's R83. And here is my connections here, as you can see, hopefully. There's a little post it's got like this. There's one of those over there. Now the next step is to adjust R11 over here. I've already disconnected the power supply and plugged all these things back in again. Haven't got power back on yet. So I need to move the scope probe. That needs to stay on the negative side. There's a test point just over here. You might be able to see it's just behind this wire. There's a little post just behind here. There you go. Just see it just there. Hook that up onto the scope. To there like that. And I need to adjust R11, which is this trimmer over here, on the oscilloscope once more and adjust that. So measuring at that test point, I'm getting a 5.01 milliseconds delay time, and according to the electronic manual for this machine, that is correct. Now the 1062 has a 5 millisecond pulse time set up, and the 1061 and 1061A, which I'm using the physical manual for, says 6 milliseconds. This is fine. That's exactly what it's supposed to be. So great, we'll move on. So the next step is to measure TP7 and set it to 1.05 volts DC. Now I've got this set up on the scope already. It's already basically there. I've already done this adjustment when I first got this unit because it was wrong because of the line voltage being different and line frequency being different. So there's so it needs to be calibrated to the line frequency. So I've already done this adjustment once. If you go up on the all measure here, you can see the RMS voltage is 1.05. Fluctuating very slightly. Now there's a lot of high frequency noise in here, which makes it a little bit trickier to actually get the reading, because you can see you've got a minimum and maximum here which are outside of that range. Obviously, right, so it's doing a bit of averaging there because it's got high frequency noise. There's a lot of ripple in that particular section because it's this is the way that power works. Anyway, so I've got that 1.05 volts plus or minus 0.03. So as long as I'm sort of hovering around that 1.05, then that should be good. Now the way of improving this, obviously I could do AC coupling and look at the noise in there. I could do that way and show you that. So let's wind this up and change the frequency here, and you can see there's the high frequency noise which is present on that signal. Alright, so that's what we're trying to deal with, is this noise. So yeah. Alright, so that completes the digital board calibration, right? So that board there is now done. Now I need to come over here and look at this board. I should clarify actually. The next step of the digital board is to actually wipe memories. So you wipe the calibration out and start again. Now I don't want to wipe the calibration out. I want to keep the existing calibration intact and then move on and see how close it is at the end. If the digital calibration is wrong, that's fine. I have to wipe it and start again anyway. But I want to see if it's actually okay or not. So although I've done those adjustments, I should be bringing it back to where it should be originally. They won't adjust it by much. We'll see how we go, but hopefully that doesn't actually wipe anything out. But we'll move on to the next board and sort this one out. Right, so the next step is to stick a 10 mega ohm resistor across the input on here, DC volts, 0.1 volt scaling, and I've got to adjust some things over here to do the adjustment. So apparently I've got to center a couple of the adjustments already here and then set R159, which is this one just here. R159 is right there. I've already gone through and marked a lot of these adjustments, so it makes it a little bit quicker to try and do the adjustments. And okay, obviously that one there, that one there, so I can look it up and figure it out. As well as some of the test points. I've done all the test points, especially this section over here is a little bit different in layout from the physical manual we're sitting over here on the side, which is for the 1061. The board is slightly different. But I do have the information in the electronic manual, which is a bit harder to see in there. So I've done the ones which I can see off the, easily see off the physical manual, just to make it a bit easier. So anyway. I've got my test leads hooked up to TP20 and TL8, which is also called TP13 on the older manual. Well, the 1061 manual, same test point, but it's got a different number. Don't know why they've done that. Anyway, so those are the test points I'm using here. And this is with a 10 mega ohm across the inputs with a 10 nanofarad capacitor also across the input, which you can't quite see, it's made a shot. It's down here. So I've got both across the inputs are here. That's on DC volts, 0.1 volt resolution. And I'm adjusting, I've already zeroed a couple of these positions, and I've got to adjust R159 for less than 10 millivolts. This is more of a verification because this has got a pre-selected value resistor in here, and that's also been done by the factory. The idea is here is that we verify that it's actually correct still and it's not drifted off. I did actually play with this already just now, so that put that back to 0 there. So R150 and R160 should both be zeroed, or centered I should say, and then R159 is for trimming the value I'm getting. So that's currently fully anti-clockwise. As I'll turn it up, I'm getting a drift. Now I'm getting an interesting drift here. So fully clockwise I'm getting minus 11 millivolts. Fully anti-clockwise I'm getting minus 2.5 millivolts or so. So it says less than 10 millivolts. I'm thinking, well, should it be 0 millivolts? Does it matter if it goes to negative? I'm not sure. It doesn't actually specify. Anyway, moving on. Next step is to stick a short across the inputs. So I'm doing that with this shorting bar. We'll shove that in there. It gives us a nice sort of short. You don't have to take those other parts off because it's a short, shouldn't matter. And next thing I look to do is adjust this for R150, or adjust that for less than 50 microvolts at TB13. So same test point, less than 50 microvolts on R150. So this one here, I'm currently seeing at 3.5 millivolts. So maybe this will be what I need to do, I don't know. Anyway, less than 50 microvolts. That is very touchy. I guess that's kind of the fine tuning, really. That gets it roughly right, that gets it closer. I guess so anyway. So I'm currently sitting at about 24, between 20 and 30 microvolts. It's jumping around a little bit there, obviously a bit of noise. But that will be within spec. It says less than -50, so I can probably get it slightly closer. This one I'm adjusting, so I'll put little marks on where the original adjustments were. The original R159, I put that back to the original mark and just left it there. And R150, I've turned it slightly here now, so it was slightly off compared to original. But then it could be to do with this. I mean, this one does shift it off. If I stick that fully anti-clockwise, for example, then I can use this one to do the same kind of adjustment. So these two look pretty much work in conjunction with each other. If I put that back to where it originally was, I'm inclined to do that in case it was a factory original adjustment, because there's not really much benefit in not doing that. So I might as well leave that there, and we'll trim this one around to get that value we want, because it will get there anyway. So let's try and go for 0 if we can. This is where multi-turn pot would be quite nice. Let's go slightly negative. I don't want to be going negative just in case it matters. Yeah, it's floating around slightly, but it's basically about 3 to 4 microvolts, so I think that'll do. Now the next step I've got to do, I've already moved the connector over here, so this is on TP33. I've got to adjust for less than 20 microvolts if I haven't lost my screwdriver. Right, it says R160 we've got to adjust, which I've got centered still right now, sitting at 43 microvolts. So I'm going to turn towards the original mark. Yeah, and that's actually pretty close. So the original mark is giving me about -41. So it's in between those 2 points. So stick it there, and that's basically 0 right there. So it's slightly off the mark, but not much. I don't really even see that with the lighting stuff. There you go. So pretty close. There's that one done. You're supposed to keep going backwards and forwards, looping through all those adjustments until they all come right. So let's just go back over here and recheck this one over here on the TL8. That's reading -35 or so now, so it's shifted slightly. So let's readjust 150 again. Let's get closer to 0, which is the other way. So I have to obviously repeat this process until they're all stabilised and behaving. And this one's very, very touchy. Yeah, it's now saying about 10 to 15 microvolts on there. Let's bring it back over here, recheck this one. That's basically saying 0 still, so maybe 1 microvolt, which is well within. Right, so I've skipped a step because I don't want to do that part, because it shouldn't be necessary. It's like a preset factory setup thing, so I shouldn't need to do it. Apparently it only says you only have to do it if you've replaced the components in a part of the section, or in that section of the circuit. So I haven't done anything with that section, so it should be fine. I shouldn't have to change anything. So I'm not going to adjust that, which is for this adjustment over here, R151 I think it was. So no need to do that, I'm skipping that section. So the next section is about verification of the reference, which is over here. So let's unplug this one from here, go to TP7, which is here, and they should read about 6.42 volts plus or minus 0.03 volts. So I can go from 6.39 up to 6.45 volts at that test point. I'm getting 6.435. So the reference diode, the Zener, which is in here, is still absolutely fine. I don't have to do any tuning on that. It's still well within spec. I've changed over to TP8, which is the same deal. I have to do the same kind of check. This is a negative voltage reference. That's minus 6.4338. So it's very slightly lower than the other one, but it's still well within spec, because it's got to be within 0.03, as I said, so it's absolutely fine. So TP9 is over here. The next check is to be on hold range. Just going to unhold it and then rehold it again since I've changed ranges. Now I need to make sure that the voltage at TP9 here is less than 1 millivolt. Well, 0 volt plus or minus 1 millivolt. And this is another for a factory selected value resistor. And this is more verification that it's actually still okay. And I'm getting 0.39, so 390 microvolts I'm getting, so that's within spec, so I don't have to worry about that part, that's fine. Alright, the next step is to check for a noisy waveform, which I'm going to show you on the scope as well. If I want to inject 19 millivolts, I'm going to use a PDVS2 Mini for that. Nice and precise. Across the input terminals, I still left the resistor on there, but it shouldn't matter, it's 10 mega ohms. This can certainly put enough current to overcome the 10 mega ohm resistance, so that shouldn't matter. And the ideal thing is to just to verify the waveform looks correct on over here. So I'll show you that. I'm hooked up over here to the test point. I'm just going to double check this test point, make sure it's definitely the right one, because I referenced this off the 1061 diagram. I need to make sure that it's off the correct one for the 1062. I'm just going to double check that. I think it's the same one though. And then I'll show you the scope. So just to confirm what I'm doing, I've got 1000 volts, holders turned off. I'm hooked up to TP21 for the negative and TP5 for the probe of the scope on the positive side. Okay, and I'll show you the scope now. And as you can see, it's a nice noisy waveform, and that's what it does mention in the manual. Now I've got to set this for 0, a noisy waveform around the 0 point. It looks like it's pretty much there, but this is for R20. Let's give us a tweak. Nothing really changing. Don't really see anything changing there. I know I'm on DC coupling as well. I think it is affecting the noise. The noise is getting smaller. You probably can't see it on camera because it's scrolling so fast. So I think what I'm actually doing here is tuning for the minimum noise. I'm pretty sure. I'm just trying to sort of figure that out. Which is basically where the mark is on the adjustment, which I put on. So I think that is actually pretty fine, really. Yeah, I think that's right. It's a bit of a weird adjustment, I'm not sure about this one, I'll have to double check it. Alright, now it says to do 1 volt range, no filter. I've got to go to calibration mode, so I've got to turn the key switch on. And I've also change the resistor here to be a 1 mega ohm instead of a 10 mega ohm. Now what it says to do is to, now the calibration key is turned on, you see cal on display, and select linearity, which is over here. So I've got to push this button, let it do its thing, and the light will go out when it's finished. It's just a bit of a slow process, I think it takes a while. There we go, it's off now. Alright. The next step is to put the 10 mega ohm back in again, which I just took out, which is a bit annoying anyway. We shall do that. Okay, 10 mega ohm is fitted back in again. And now I have to do the IB button instead, which is probably that middle one, but it's a bit hard to read. Yeah, it is, it's that one there. This one has got the front panel damage, so bit of a sacrifice. Anyway, push that. Let it do its thing, and then that should be repeat until display reads less than 50 digits. So that's jumping around an awful lot, isn't it? Not sure it should be jumping around that much. Well, I think I'm just going to leave it as it is. I mean, I've done that, but it's jumping around a bit, so I'm not quite sure it's just because it's such a noisy environment and it's causing it to jump around a bit. If I plug the short-in jumper in, it's fine. So it's not like a meter fault or anything like that. So we'll just move on to the next step and we'll see how this turns out. So the next step is to go to 10 volt range, apply an input filter and shove a shorting link in, like so. And I need to do a 0 on this. So 0 is this button here, and it has indeed zeroed. Now I need to apply 10 volts and see if it comes up as 10 volts. Alright, so I'm applying 10 volts exactly from the PDVS2 Mini, and now we have to hit gain to set the 10 volt threshold. Might do it a couple of times. Almost there, do one more. There we go, 10 volts. Okay, so now it says to inject a 19 volt power supply. So I've hooked up to my big bench power supply here because my PDVS2 Mini only goes at 10 volts, so it's not as accurate. But what I've done is I've hooked up to my Siglent as well to another cable. So I've got both meters reading the same thing, so I can verify in the Siglent what's actually coming out of that power supply, and then I can verify against this. So let's increase this up to about 19 volts. Okay, so that says 19.006. My Siglent says 19.006. That's linear, or at least pretty damn close to it. So I'm happy with that adjustment there. That's good. That linearity looks absolutely fine, well within what I expect it to be. So I don't actually have to do adjustment. That's R23 just over here, which is for doing that linearity adjustment. You make sure there's an offset difference between the scaling, and you do a calculation on that, and you work out what you should set it to. So that way it's linear across the range, and obviously I don't think it needs to tune because it's close enough. I think it's basically right. I'm just going to leave that alone. It doesn't need changing. So what this means is I'm going to have to go through and do a calibration on the unit, because although I've done that adjustment on the 10 volt range as per the instruction manual over here, the 1 volt range is wrong still, and I was hoping that would be corrected by what I've been doing. Obviously that's not the case. If I do 100 millivolt range, same deal. So I'm going to have to go through and do calibration. It must have lost the calibration constants at some point, or someone's reset them or something, because obviously just doing that adjustment hasn't done the job. So, and that was what I was hoping to fix it, and it's not been that. So I'm going to have to go through and calibrate it. That's not a big deal. So I'm going to do a calibration on this Datron now, and I'm only going to show you the DC section. I'm going to show you the rest to give you an idea, because it takes such a long time to do. I haven't got the calibrate mode turned on yet, but I'm just going to show you what I've done. So I already did the basic calibration yesterday. It's kind of there, but it wasn't actually warmed up properly and that sort of stuff. So what I'm going to be doing is a calibration comparison against the HP 3457A showing 6.5 digits. Right, so they're basically like for like. Really, if you're doing a calibration, you'll be doing an extra digit, 10 times more resolution you've already got. So I don't actually have that, so we're just going to match it to this one. It's going to be good enough, I suppose. So I've got my Fluke DC calibrator down here, and I'm also going to be using my Fluke 5450A as well, my resistance standard. I need that to do a linearity stuff. You have to inject a resistance on here. Now I did actually make some jigs up, these things. 1 megohm, one's 10 megohm with a capacitor across them, a 10 nanofarad capacitor. These are used for checking linearity and stuff like that. And the problem is that after I soldered them, the 10 megohm one turned into being 11 megohm, which is helpful. And the 1 megohm's fine, that's actually still correct, so I can still use that one, that's right, it's still 1 megohm. That didn't change. Obviously, because it's the carbon film, it didn't like a bit of heat and it changed its value, which is a real pain. This one's metal film and it didn't bother it. So, but I actually chose these based on the accuracy of the readings I was getting off them. So this one's basically almost exactly 1 megohm. It's only about 1% out or something like that. It's pretty good. It only requires 5% accuracy, but I thought, well, the better I go, the better. But because this one's drifted off so much, that's 10 megohm one, I'm going to use my Fluke to provide a 10 megohm reference and stick a capacitor directly across the inputs, and hopefully that'll be good enough. We'll see what we get. I'll do it that way instead. Probably a bit less ideal, but that's what I'm going to do. So I need to start off with doing these shunts across here to actually calibrate these linearity stuff. So I'll show you the manual in a second. So here's the page of the manual we've got to follow. You can see the first section here is the 1 megohm resistor, and that's actually, the manual states that you use a 10 nanofarad capacitor with that in order to reduce noise. So 1 megohm's fine, that one can work, and 10 megohms we've got to inject the Fluke instead to try and get that right. And then we basically go through, do the zeroing of each range, and then we go through and set up the ranges of each range, up to 1000 volts. But the 1000 volts I can't reference against the HP because it can't do 300 volts max. So once I get up to that level, I'm going to have to stop over something else, but by then I think I'll probably stop recording because you get the idea anyway. It get a bit boring after that. So I'll show you the first stages anyway. Alright, so let's get this thing going. So I've got to flick the calibration switch on the back. There we go, now in calibrate mode. I need to go to 0.1 volt scale, which is what I'm already on. DC, I'm already on that. Filter is in, that's already on. So now I need to do the linear button. Alright, so linear is this one over here, linearity. So what I've got to do is put the little 1 megohm across here. This is what's required first. Put it down nice and solid. Nice, there's 1 megohm across there. And now I've got to do the linear button. Or not. Okay, I got it wrong. I need to be on the 1 volt range. That's why it didn't work. So 1 volt range, then push the linear button. Here we go. This will take about 20-30 seconds, something like that. And then once that's done, we swap over, put in a 10 megohm. And yeah, it's already done that one. That's pretty quick. There's a 10 megohm on the 0.1 ohms. Sorry, 0.1 volt range. Right, so that's the resistance calibrator hooked up, set to 10 megohms. I've got a little 10 nanofarad capacitor shoved across the inputs directly there. Try and keep noise down. Let's go to 0.1 volt range and we'll see if this is quiet enough. There is a little bit of jumping around there, but it's not that bad, I suppose. So now we have to do the IB, which is this button here. That's that one there. So apparently you have to push it a few times until you get less than 100 digits, they say. I suppose I say 100 counts, but it's sort of floating around over here. Me moving around probably is not helping. But this one seems fairly unstable in this regard, so we'll do it again. Yeah. I'm not sure about the stability of this particular measurement. That seems reasonable there, doesn't it? Yeah, I think I'll do. Next step. Now the next step's to do zeroing. So I've actually hooked it up to the DC calibrator again already. But what I'm going to do now, instead of using the zero on the calibrator, because the calibrator may be slightly off, so I'm going to shunt the terminals together. Right, that means you've definitely got zero potential difference across the two inputs. And because I already did the zeroing yesterday, it should be pretty good. It's looking pretty close. So I'm supposed to do 10 volt range first. And we'll see how we go there. Right, so it does have a slight difference. It is a bit warmer now, but when I did this yesterday, it was a quarter temperature, it hadn't been on for as long, that sort of stuff, so it wasn't actually properly calibrated. So I'm trying to get it closer this time. My intention is actually to sell this unit, so I just want to get it so it's definitely okay, definitely good, and then I'll actually list it and I'll sell it. Let's do zeroing on 10 volts. So zero button. Sometimes you just do it a couple of times, let it settle, that sort of stuff, but it looks okay. So now I've got to inject 10 volts. As you can see what I'm doing 100 millivolts, so I've got to do 10 volts, so I need to change this ranging. 10 volts. Now we need to make, this says basically 10 volts on here, so I'm just going to say it's 10 volts. You know, within a few counts. You can see this is very slightly different to yesterday. Just a few counts down, you can almost leave it there really, but I'm going to show you anyway. So I'm going to do a gain on that one. That'll set the 10 volt point. Okay, and now what I've got to do is actually reverse the polarity on this connector. So I need to get this, and I think I actually have to do another zero first. Yes, I do. So we did a gain on that one, then we do a zero. Just to make sure it's definitely okay, I'm just going to verify it looks okay. Looks good. Do another zero. This is what the manual says, even though it says it's fine. Alright. Then we do the negative 10 volts, which is reverse polarity. Okay, and then we hit gain again on this one, and that sets minus 10 volts. Okay. Now, I'm thinking my calibrator is slightly high because this meter is reading slightly high, so I probably have calibrated very slightly off. So I'm actually tempted to correct that because this one is reading slightly high. So if I was recheck that way. So what I could actually do is tell it that this is the number. Right, if I check the filter on, that'll average it out, and that'll tell me exactly what I should be setting it to. Right, so about 5 counts out, which is like negligible really. It's almost nothing, not really worth worrying about. But for the sake of completeness, let's do it properly. So 10.00005 gain. Okay, so that now thinks that is that voltage, which is what it should be actually. Okay, so we'll do that zeroing again to make sure it's definitely looking alright. Still good. Do the negative one. We'll probably do the same thing again. Alright, that still says that 10 volts exactly, so we need to make it negative. So we have to go negative. So negative 10.005. Well, that's shifted slightly. We'll stick with 5 for the time being. And it didn't do it. It's the same -10. So it looks like when you try and do a negative number, it won't actually accept the keyboard input, it just ignores it. But doing the positive, it will. Interesting little quirk, isn't it? Little firmware bug, looks like. So go back to the other way around. And that one's correct. Pretty much. Yep. Now you're basically agreeing within a few counts. Stick with 0 on there again. It's looking alright. So basically that's the process you do for each range. Exactly the same thing. If I chuck on my PDVS2 Mini instead, okay, it's saying 10 volts there. This is averaging. So this is actually reading 10 high. So what I was actually getting at my calibrator was actually correct, because this is slightly off. I trust this thing pretty well. So I think we're actually pretty good there. I mean, it's close enough. You're talking about, 10 counts pretty much being out. So I think that's good enough, really, in reality. This thing stabilises pretty quickly. It only takes like 10 seconds to be fairly stable, to be honest. It doesn't actually change that much after that point. Okay, so that basically agrees with the calibrator, so I think that's close enough. So let's set my DC calibrator to 1 volt output exactly. Well, pretty much exactly. Very close. You can see it's giving basically 1 volt on here. So let's do 1 volt range. It's the next scale we've got to do. This thing's still doing some averaging, so now we can do the same thing on this one. We'll do a 0, then a gain, another 0, then negative. Right? So we'll 0 that. Give it a chance to stabilise a little bit. So I'll do a gain on this one. Though this voltage has crept up very slightly, so maybe I won't do that just yet. Okay, let's do it there. Although they're basically agreeing, actually. They're still pretty good from yesterday. So this is calibrated before I got it, so this is actually my sort of trusted source right now. We'll do a 0 or gain on this one. Let's call that 1 volt. Do it again. To drop down for slightly. There we go. Yes, I'm being fussy. Right, so now we'll do a negative. So check the zeroing again. Looks alright. -1, that's slightly off, so I'll do negative. There we go, -1 volt done. Check the zeroing again. Still 0, okay. Looks alright. Go to the positive side, that should still be 1 volt. Cool. So now I've got to do the same thing for the 0.1 volt range. So I'm still in 1 volt range right now. I'm still in 1 volt range right now. See, it's looking pretty close. It's 100 millivolts, obviously. And you can see there's a difference between those two ranges. Okay, so this one's looking closer than this one. So you can see up here on the HP what we're actually getting at the calibrator. I don't have filtering turned on, so it's, you know, real time. I mean, this is probably closer there, that particular point there. If I turn the filter on, we'll see what we get. Right, so it's looking pretty good there, pretty much exactly right. So we'll set this one to that. So first you have to do 0, as before. When you get down to these millivolt levels, it gets a bit harder to get these things right as well. It gets a bit more touchy. Ooh, yeah, close enough. Right. And we'll do a gain on this one. Okay. Might have to do it again if it's a bit unstable. Maybe one more. Because to talk about microvolt levels down here, you know, that's 1 microvolt there. So, you know, it's going to be a little bit touchy about any kind of environmental noise. So let's do the negative direction. Check the zeroing, still looks good. Do it anyway. Reverse polarity, show it back in. And we'll do a gain on that one as well. And I think that's pretty good. Good enough. Back to the positive. That drifts off very slightly, I think. Oh no, that's alright, settling. It's close enough. A few counts out, it's close enough. So that's the 0.1 volt done. So now I'm doing my 100 volt range, as you can see, get 100 volts set up on the calibrator. So I need to shut this off so I can disconnect it. Don't want to get zapped. Shut that in there. Check the zeroing. It's off by a little bit. Zero it. Okay. Shut the back in. Turn the calibrator back on. Let it stabilise again. Okay, let's do a gain. Maybe again. Okay. Shut the calibrator back off. Check the zeroing. Hit 0 again. Reverse polarity. Turn the calibrator back on. Let it settle again. And that's actually looking really good. I think I don't have to do anything there. It's bang on. That's absolutely fine. So cool. So that's up to 100 volt range done. Now I'm not going to do the 1000 volt range because in this particular setup, because this can't take it or I end up blowing it out. So obviously I don't be doing that. So 1000 volt range I'll do separately. I won't bother recording it. I've got to mess around my setup here and do that. But you get the idea of what I'm doing here. So hope you found it interesting. Maybe. I don't know. Do it out a bit. Catch you later. Thanks for watching. And I'll see you next one. This is the number up.